Let's talk more about Numpy vectors, or arrays. In previous session, we discovered 3 ways to make an array. Now we're going to see more. We have a function called arrange, or maybe arange, whatever. We define our variable as np.arrange. It is similar to range function. It takes 1, 2, or 3 arguments. The first number is the start, the second one is the end, and the third one is the step in our range. Here I created an array from number 1 to 12 minus 1, which is 11. We have type conversion too. I can determine the type of each number in my array by using dtype after my arguments. Let's say it is equal to float. Now if I print the array, you can see all numbers from 1 to 11 are float numbers. As I said before, we can also use only one argument. If you type one number, Python considers 0 as the first number. This example shows how you can put numbers from 0 to 9 into an array. So writing number 10 as the argument means the array starts from 0 and it continues to 10 minus 1, which is 9, I believe. Now let's make it from 1 to 20 while the step is 2. So the first argument is 1, the second one is the 21, which minus 1 is 20, and the last one is our step, which is number 2. Now you can see we have only odd numbers from 1 to 20. Another useful function is the linspace. Let's define a is equal to np.linspace. The first two arguments are again the start and the end. The third one determines how many numbers are between them. Remember, the distances between all numbers are the same. For another example, let's make an array containing 20 numbers from 1 to 5. As you know, all these numbers from 1 to 5 are floats, so you can change them to integers if you want. As you remember from the previous video, an array is like a matrix. But of course you don't need a key or ifs to make a matrix. Just use matrix function. Your matrix should be inside a string, and rows are separated using semicolon. Here's a matrix with 2 rows and 3 columns, which is a 2 by 3 matrix, as you can see below. Let's see an example of indexing, which is explained in the first video. Here's how you can take out number 1, which is in the first row and the first column. You can also see the transpose of a matrix by using the capital T. The syntax is like this: name of the matrix dot T. In every single matrix, if you replace the number n row with the number n column, you'll get the transposed matrix. In our example, you can see now the first row is replaced with the first column, and also the second row is replaced with the second column. The transposed matrix can be useful in numerical calculations. Complex numbers can also be used in our matrix. A is a complex number which its real part is 1, and its imaginary part is 2. Now we make a 2 by 2 zero vector. You can of course use previous methods we explained. The important thing is the array type. We want it to be complex. Now we put our complex number which is inside variable a, in the first row in the first column. So this one is an example of a matrix involving a complex number.